The Etch-a-Sketch has helped spark creativity ever since its release back in 1960. For over 50 years, creative minds have produced fine pieces of art using the vertical and horizontal knobs provided. The year is 2017, San Francisco State, Mechanical Engineering. The goal for our final project for our Engineering 415 Mechatronics class was to make a mechatronics system integrating one of the Etch-a-Sketches with necessary mechanisms, sensors, and actuators so you can draw a range of images, from simple lines to shapes to complex images. Over the course of 4 weeks, my partner and I have worked countless hours to make our professor's vision into a reality.
All right.
Go for it.
This is our 415 project, the master-slave Etch-a-Sketch controllers. Here we have a 3D printed base and gears, one-to-one gears, feeding into the rotary encoders. There are two individual boards here driving the X and Y knobs for the Etch-a-Sketches. Power has been an issue for these, so there are two USB cables feeding into my computer, powering these ULN 2003 boards. These boards seem like they're very inefficient. We've hooked up 9-volt batteries to them, and they've drained those batteries to a point where they don't drive the boards anymore, or the motors, within 10 or 15 minutes. This is the master unit. Here we have the Y knob, and as you see between the two, when we rotate the Y knob, it'll start tracking on the slave unit here. This is the X knob. You see when we rotate this one here, it'll start to track on the slave Etch-a-Sketch.
Okay.
This portion, we're going to speak on the coding environment and the various programs we use to make both the master-slave Etch-a-Sketch and also the Gerbil drawings. This code for the master-slave was found online and was very well annotated, and everything was described really clearly, which aided us in the speed of producing our project. What we worried most about was the accurate fitting and powering of the electromechanical elements of the project. Moving on to the Gerbil portion of our project, which will be the drawing of several simple shapes with the slave Etch-a-Sketch. A hex code build of Gerbil designed for the Arduino Uno board was produced by a user on GitHub and made available to the community. With the program Xloader, we were able to put the hex file onto this. The hex file is a lot like the Arduino programs that we've had powering our master-slave. Several simple sets of inputs, libraries internally. Gerbil will have its own libraries on how to control numerous different extensions of the Gerbil, coolant, x-axis, y-axis, probes, any sorts of periphery that's attached to the Arduino will be part of those libraries that are included in the file. After uploading the Gerbil program into the Arduino, we were able to communicate with it with the universal G-code sender. This program allows us to import .nc files.
Hey guys, so I'm gonna go ahead and show you the 3D modeling for the Etch-a-Sketch project. So the first 3D CAD drawing I have here is the Etch-a-Sketch knob. So it's the actual knob that goes right over the Etch-a-Sketch knob. I went ahead and drafted it into Fusion 360. It actually fits really nicely. So then after that, I went ahead and designed a holder for the Etch-a-Sketch. So as you can see right here on the screen, So I can even show you right here. So this what we have here is called a lap joint, right? So all you have to do is put a couple screws right into here, and it holds the holders right in place. We felt like this was, me and my partner felt this was the easiest and the most reliable design that we could have came up with. We're pretty happy and satisfied with how it turned out. So this is for the slave component. So for the master component, as you can see here, so we really like the design that we already had as far as the holders come into place. So the only thing I really added for the master component was this little holder right here. So that holder is for the rotary encoders, right? So the rotary encoders, they rest right here on the holder. You have the rotary encoder, and then the next design we have is the shaft gear. So it's actually the knob shaft. So it's in two separate parts. So it has the actual knob, and then a shaft, rectangular shaft attached to the knob, and then you have the I call it a shaft gear. Yeah. Then you have the actual shaft gear that goes right on top. It sits right on top of the rectangular shaft. And then you have the actual gear that rests right on top of the rotary encoder. So as you turn one knob, then it rotates the rotary encoder. Obviously that sends a signal right to the Arduinos, and that sends a signal to the slave components. So yeah, there you have it. We drafted all this. All of this was possible in the using the Fusion 360 software provided here on campus.
This project was a lot of fun and allowed a lot of us in class to come together and brainstorm ideas. What we can definitely take from this project is that we will soon become engineers ready to take on the next project that's handed to us. We'll look back at this project and remember those who helped guide us along the way, while making lifelong friends in the process. After all, with a little engineering, who knew you could turn a childhood toy into an awesome mechatronics system?